So let's do this one, hopefully better than the last one. Does it give us a fraction? I don't think.
I don't think so.
All right, so we're going to start with horizontal because it's the easiest one. All right. A greater on the top than the bottom means I don't have one, right? So I do not have one. All right. Vertical. So for vertical, we are going to want to, factor. All right, so we'll factor the top and the bottom here because we need to know if it's a whole or if it is a vertical. All right, so we'll do our verticals and our wholes together. All right, so on the bottom, I have a 2 that is going to give me a 0. Does that cancel?
Yes.
Yes, so I have a whole at x equals 2. That's the only thing on the bottom that gives me a 0. So what about vertical?
It's x or 3. Wait, no.
Intercepts. So y-intercept is when x is 0. Yes? So 0 minus 4 over 0 minus 6 is positive 2/3, right? So that's where it's going to cross the y-axis. All right? X-intercept is where the numerator is 0. All right? Except one of the places where the numerator is 0 is a whole, correct? All right? So the x minus 2 I can't consider as an intercept because that's where a whole happens, okay? So I can only consider it at the x plus 2. Yes? So at the point -2, 0, I will have an x-intercept, right? All right, so I am looking for x-intercepts where my y is 0 or where my numerator is 0. My numerator is 0 at -2 and +2, right? But I have already, +2 has already been designated as a whole. So you cannot be a whole and an intercept. That's counterintuitive, right? Intercept means where it crosses it. Whole means it actually doesn't cross it. So those two can't occur at the same place,
So
all right?
we're just plugging this.
So I cancel them out and I get x plus 2 over 3, right? If you plug in a 2 there, you'll get 4/3. And so your whole is actually going to occur at 2 4/3. That's where that whole is going to happen.
Wait.
All right, so let's graph what we have. We do not have any horizontal or vertical. So this is going to be a much different graph. We have a whole and some intercepts. So I'm going to go ahead and graph my intercepts because those we're very familiar with. And I'm actually going to zoom in on this thing because it's a much... I can't see my holes anymore. Let me move these guys over and then we'll zoom in. Okay. All right, so we're gonna, that way y'all can still see what I'm doing, but I can zoom in a little bit. All right, so. All right, so I'm gonna do my y-intercept. 0 2/3, that's going to happen about right there. My x-intercept is -2, 0, right? And then this is where my whole comes into play. So at 2 4/3, which was about right here, I'm going to have a whole. All right? That's too high.
Yeah,
It's too high. My graph is, there's my one. There we go. 1 1/3. All right.
It has to be the open circle.
It does have to be an open circle. What does this look like?
A line.
It does look like a line. So let me show you. Remember when I canceled? What was left over when I canceled? We talked about this a little bit. I was left with x plus 2 over 3. All right. There's another way to write that. 1/3 x plus 2/3. That looks vaguely like y equals mx plus b. The difference is that right here, instead of a line, I have a hole. All right. And so my graph actually looks like this. All right, so the first thing to review is just simplest form. What does it mean for simplest form? Simplest forms means that you can't reduce it anymore. Think about it from just a normal fraction perspective. If I said 4/8, everyone should know that's not simplest form. You should be able to write it as 1/2. And so that same concept can happen with rational expressions. Rational expressions means a polynomial over a polynomial, All right. And so for simplest form, what you're basically doing with 4 over 8, just to make it even more difficult than it should be, right, is you're basically factoring it, right? And you're saying, well, I can factor it into its simplest form each, and then I just cancel out what's left. And you can see you get 1/2. Obviously, we know divide by 4. But what you're doing is you're taking out a common factor and you're dividing it out and simplifying it. That's what you're doing when you are simplifying fractions. All right, so we're going to do that same concept with rationals. Let's look at the first example. They give us this guy here. Simplify and state any restrictions on the variable. So your first step for these is to factor everything. Factor the numerator, factor the denominator. That is the first thing you are going to do is you're going to factor. And so in the numerator, I have x squared plus 10x plus 5. Factors of 25 that add up to 10. 5 and 5. In the denominator, factors of 20 that add up to 9.
4 and 5.
Yep. State any restrictions. So before you start canceling away to reduce, you want to determine your restrictions up front before you cancel things, because your restrictions are on the original equation, not your simplified one. All right. And so the next thing you're going to do is you're going to look for limitations. So restrictions are things that would cause a hole or a vertical asymptote. All right. Those are restrictions on your domain. All right. So restrictions are what you're going to look for next. What are the restrictions? There are 2 on this one. X cannot equal what? -5 and -4, right? Why can't it equal -5 or -4?
So it can't be a vertical asymptote.
Or restrictions, it means if you were to graph this, would there be something on the graph that indicates the graph doesn't go there? A vertical asymptote, right? You never touch a vertical asymptote. A hole, you never touch a hole. Your graph itself does not go through those things, right? It jumps over them. And so by restrictions, they mean restrictions on the domain. Is there anything x cannot equal? If x equals -5, I have a problem. If x equals -4, I have a problem. Those are restrictions, okay? The last thing you're going to do is simplify. When you simplify, you cancel everything that can cancel, just like you would in a fraction. What can cancel here?
X plus 5.
The x plus 5. Only one of them on top. So my simplified form looks like this. X plus 5 over x plus 4. If I did restrictions here, it would look like the only problem is -4, right? But for my original, I can see -5 is also a problem. So -4 and -5 are my restrictions. So you would tell Multiplying. You literally, same step, Monday. Factor everything. So for multiplying, factor everything. So you're going to factor 2x squared plus 7x plus 3 and x minus 4 cannot be factored. All right, x minus 4 cannot be factored. So factor this one. X minus 4 cannot be factored. All right. Factor this guy. That's a special case. How do I factor him?
X plus 4, x minus 4.
Yep, x plus 4, x minus 4. Factors of 15 that add up to 8.
Oh, 7, 3, 5.
Yep.
And 7.
Okay, for this one, when you're multiplying fractions, you can multiply any numerator to any denominator. All right? Not just top and bottom, but diagonally as well. All right? So I'm going to go through all of these. Does the 2x plus 1, can that fact cancel with anything on the top to the bottom? No. So this is what I do so I don't lose them. All right? X plus 3, can it cancel with any bottom? Right there. All right? X minus 4.
Yes.
All right? X plus 4.
No, man.
X plus 5.
No.
So in the numerator, I have 2x plus 1, x plus 4.
Over
And in the denominator, I have x plus 5.
Okay.
Now,
So they have to cancel.
so they foil it. I do not. I do not make you foil these. You may leave them in factored form. The reason I don't make you foil them is as you go along, if you were to have to use this, it's often easier to use it in this form. So I don't make you actually go through and foil it. All right? Keep, change, flip. That is division. So I'm going to keep the first one identical. 4 minus x over 3x plus 2, x minus 2. By the way, you do have to factor these for me. So you want to flip it first. Keep, change, flip first, then factor, then cancel. Okay? So multiply, and then it's going to be x minus 2, 7y. Is yours a y? Minus 5 over 5. X minus 4. You're going to keep, change, flip first.
Okay.
Then you're going to cancel. So remember I said if they're exactly opposite, 4 minus x and x minus 4,
You just take out
I can take out a negative 1 here, and then I can cancel those because that becomes x minus 4. All right. 3x plus 2, can that cancel with anything?
No.
No, it cannot. All right. X minus 2.
Yes.
Yes. 7y minus 5.
No.
5. By the way, there's a reason I'm boxing it. It's more than just instruction. What do you think could potentially happen to something like that 5 if I'm not boxing it? You forget it's there and your final answer, it doesn't show up. All right? So your final answer is negative 7y minus 5 over 5, 3x plus 2.
Like I forgot about the 1.
Right. Yeah, and I didn't even box it, but yeah. So boxing is how I determine if I actually pulled everything down, and I can go back to it. They distributed, but either way is fine. I would take either one of these. They distributed that, and they have negative 7y plus 5 over 15x plus 10. Either one's fine. All right, so go ahead and try 4. For 4, you have to factor them.